G'day guys, got a GPZ, GPZ, is it a zebra or is it a zebra? Anyway, it's a GP, that, Z, whatever. And I'm going to pull it apart. I've already taken the main unit from the detector. You just hit the tab here, slide it out, undo the two connectors, one for the coil, one for the control head, slide them out, and then wiggle this tab and slide it a bit more, and this will come off. When you do all this, make sure you have the battery disconnected like so. And the other thing as well, you have this sticker here, and if you pull this off, it'll leave its the underside of it behind, and you know it'll be a mess, and everyone will know that the detector has been opened. Not that it makes a big deal if the detector's out of warranty, but I'll show you a trick to get the sticker off without destroying it. And this goes for any of these metallized stickers that, you know, what is this sticker anyway? I don't even know what it is. It's a, it says it stop counterfeits on it. Stops counterfeit detectors. So obviously this is indicating it's some genuine detector. Well, I hope it is. I hope the Chinese haven't knocked these off yet. Don't think so. Knocked everything else off. But anyway, what I do, this is how you do it, right? This stuff, white spirit. And what it actually is dry cleaning fluid. And on here it says turpentine, however you say it, substitute. And it's UN 1300. I know there's a lot of different solvents around that probably could do the job, and in different countries they're called different names. So the one that got me was where is it? Over here. I think in Australia and the UK this is basically ethanol, which has been made to taste really bad by having methanol added to it. They do that so people won't drink it, because it gets you drunk, but if it's got methanol in it, well, you might go blind and your kidneys might fall out. So I wouldn't drink it. And because the way they've done it with their denaturing, they call it, you can't distill it out. It comes off at the same fracking temperature, so you can't turn it into pure alcohol. So, but I know methylated spirit in the US it's not methylated spirit. It's called something else. But we're not using this. This is not very good at removing the stickers. What you want is something that eats through the glue and doesn't affect the plastic. And this is the beast, right? This is in Australia. The brand is Diggers. How appropriate, Diggers, get it? Okay, white spirit, dry cleaning fluid. So it just says 100% hydrocarbon liquid. So if you ask around for dry cleaning fluid, you'll probably get the right stuff. This is made in Queensland. Yeah, so anyway, that's what it is. Looks like, smells a little bit like turpentine, and when you heat it up, it smells like the back end of a jet aircraft. So obviously something like kerosene, but it's not as rough as guts as kerosene, and it's not turpentine as such. So if you want to do this properly, this is the only thing I've found that works reliably. I know I've raved on enough about that, but to get the sticker off in one piece, what you got to do, cotton buds, and you need something. These are very, very pointy, but under very light tension to tweezers. I can push that in real easy. You don't want something that wants to spring out really hard because it'll put too much pressure on. What do I do? First of all, dip this in that white spirit. And I've already done this on this side, so I should have shown you me doing it. But if I open it here in the corner, I don't know if you can see that, but I can actually get under there. Okay, and you can start lifting. If you open it up a bit, get a cotton bud, dip it in the dry cleaning fluid or whatever it's called, the white spirit, and start getting it in there. Squeeze the cotton bud on the side there, in here, like if that was loaded with white spirit, push it there, get it in, and eventually it'll loosen up and you can get something either like these tweezers. Just let it push don't push it in hard. Take your time. It could take you half an hour to remove one side of this sticker. But to make life easy, what I've done here is I only done this side. It's the only bit I need to get off because I just want to take off this black bit from the blue bit. So have a look at that. There's a sticker. I haven't destroyed it. You can see that it's still silvered and I haven't lost any of the information that is on the sticker, that if you rip this off, it would mangle it and you couldn't put it back on, that it would look perfect. This still looks perfect, even though it's had a bit of a rough life because it's been on the bottom of the detector. That's to be expected. But normally when these are on the bottom of the detector, which I put all my bits in here, it has this partially protective plate goes over it, which just screws on there. So that's how it looks. Two screws pop off, one there, and off that comes. Now I've already gone around and removed all the screws around here, and the one to take note of is under the sticker there's a screw hole. So I've taken the screw out of that, and make note that screw is a little bit longer than the rest, so don't muddle that up, or else you might put it in one of the other ones and it might do something and crack the case. So just remember that one there's longer. So we've got it to here. Okay, no battery. We don't want the battery connected. Nothing else connected with this. I'll show you. Well, because I've wiped all the glue off this, it can't re-stick and catch. Very slowly. Now, I mean slowly. Don't just go bonk, pull it apart. Don't do that. It'll wreck things. Wiggle, wiggle, wiggle. 1 millimeter or 1/16 of an inch or so at a time. Just wiggle, wiggle. Don't let it come away quick. Just keep control of it. Wiggle, wiggle. And I'll just put those battery clips in there. So they get in the way. Okay, now see, it's separating. Don't pull. The reason why, it has a mylar connector strip in there from this part of the unit to that part. Now this is also critical, what I'm going to do next. This connector here, you want to push the outside tabs very gently in a downward direction, like, well, if I'm holding it like that, downward direction, but because I've got it like that, it's going to be this way. So it goes into direction of this strip. What I do, I grab it with finger and thumb and maybe hold the side of the board there and very carefully wiggle, wiggle, wiggle. It only goes a couple of millimeters and it pops out like that. So you've got to pull this down to open those tabs. If you have a close look there, you can see the tabs are open. And if I push those, they're closed. And if that mylar strip was in there, it'd be a lot of pressure to put that back and it would hold the mylar. But when the mylar strip is out, it's rather loose. Just make sure they're like that when you put it back in. Anyway, that is the main guts of the detector. There's two boards in there. That is the Mylar board for the battery power, and also connects up to the radio, the wireless headphones or speaker setup, however you use it. Don't damage the Mylar strip. Don't yank it, pull on it. It's if you can see, it's actually like a Mylar, and it has copper, either electroformed on there. It's sandwiched, so you can't actually touch the copper, otherwise it would tarnish and go green. But these things are renowned for cracking if you bend it on a sharp angle. It's okay to do what I'm doing now, but if I did that probably 100,000 times, it would break the copper eventually. So that's why these fail. These fail because of vibration. That's why I always say, if you've got this in your car and you go down bumpy roads, any of these detectors, the GPXs and these, whatever's got a Mylar strip in it for any reason, the constant vibration, like so, it work hardens the copper, and the copper becomes brittle and breaks, and you can't heat it up and re-anneal it, otherwise you'll lose your Mylar. So that's what it is. It's got to treat it gently, and out in the field or whatever, if you go into a place down roads, make sure the car, or if it's mounted in the car, put it on a couple of pillows or wrap it up in a lot of bubble wrap or something. Never ever leave the detector sitting on the floor of the car or in the back of a ute, which is even worse. I know people that do that. And just the sharp, constant vibrations will break these. It'll start having intermittent functions, and you'll go, what's going on, the detector stuff? So be careful. Be very careful. Anyway, what I'll do is that I'll put that in the tub as well. Okay, here we come to the meaty bits. Here, this is a little plastic insert that it has two ferrite tube cores. One is for power and so forth. I think it's also for the head unit. And there's one that is on the coil, incoming wires. Now, I haven't done one of these for a while. I'm trying to remember how to pull it apart. I have done this before. I just slides out from memory, but I think you might have to lever something or wiggle something. I know it's got two plastic clips in there. I'm going to be very gentle with this. I want a flat screwdriver, a fairly decent one. I don't want a pointy flat screwdriver because it can put too much pressure on and break the plastic. I'm just having a look at that. Yeah, I'm pretty sure you push it here. I haven't pulled one of these apart for about, God, I don't know, a while. It moves, but I've got to get it past those plastic tabs there. Like I say, I'm not going to go and press it hard and have something nasty happen. But when in doubt with these things, just wiggle it. I'd say that this is some sort of clip in. When they push it in, when they manufacture these, it just goes click and locks. So it pushes the plastic apart. I might have to, hang on a second. Let's have a good look at that. How's that go? Okay. Comes back to me now. I know how to do it. I have to explain this. What they've done, another trick for new players. I do need a smaller screwdriver. I'll get a smaller one here. Now you got to remember, this is all just educational. Okay, it's all for education only. here. I don't know if you can see in there on those little black things there. They have to go in, but what they've done, they've put a dab of hot melt glue or something between them. So if that's there, you won't be able to get it apart. So what you got to do, as it's only hot melt glue, actually, I'll show you a trick with hot melt glue. If I get the right one, I don't want that. Okay, hot melt glue, you want to get it off? This is isopropyl alcohol in a spray can. Fantastic. Radio spares have this, and it wasn't that expensive, and it's lasted a long, long time. You only need a little bit. So radio spares, you're getting a free plug, unpaid, of course. And yeah, isopropyl alcohol will not hurt circuit boards or anything. So where that glue is, give it a bit of a squirt, and all you gotta do is wiggle it around a bit, and it will just fall off. From past experience, it will just come away. Hopefully. You're trying to get on the right angle here to really get onto it. But once it starts moving, the isopropyl alcohol gets under the glue and drops it off. Okay, it's coming up in a ball, so come on. It's starting to come now. You can see that white stuff there. That's the glue. You have a bit of a... This breaks the surface tension between the glue and the plastic. It does a really good job. You've got to get it working first. You've got to get a bit of movement, and it will come off. So there's part of it there. Off you come. Okay, that's what it is. Wherever the little camera is on this phone. Okay, and you want to get in there a bit more. You can see there's a fair bit of it in there actually. I think this is a part of the, when you do a video on this stuff, this is the part where you speed it up and make it run 100 miles an hour. But yeah, it's really stuck in there. Come on, come on. I have to get it off. I won't be able to budge those clips if I can't move it. So the clips move. Yeah, still, damn, I was stuck in that gunk. Okay. Come on, super gluey stuff, whatever it is. It is hot melt of some sort, but God, I mean, this one's grabbed on really well. Imagine the poor technicians trying to work on this. What do you do? Okay. Okay. Come on. It is a press fit, but these locking tabs should. It's painful, isn't it? Come on. It's coming, but it's so slow. It really is gripping hard for some reason. Maybe those tabs go all the way down the whole back of the thing, and I've got to free the whole thing up. Oh, dear me. It's going to make for a long video, this. Yeah, I can see there's tons of it in there. Out. There you go, it's more coming out. Oh yeah, it's all the way down. Come on. It's coming, but it wants to grip at the last minute. What are you doing, you think? Come on. Out. Out. Oh, it's going to be a pain. It's going to be a pain. See, it slides in and out, like so. But it wants to lock. It's got a locking tab. So I think I have to get, I don't know if you can see in there, but maybe not. It's probably too dark. But there's all this white glue way down in there, and I think the locking tabs are a continuous type thing. Anyway, I don't know if I can get the boards out without that coming out, but we'll have a go. There's no, there is a connector there, but the rest of it's all soldered hard. But you could unsolder that, and yeah, it's not going to come out unless I'm very lucky. There we go, got it. Okay, yep, and then the connector fell off, but that just clips on. It's no problem. So this is the board with a lot of the receiver componentry on it, and as you can see, what they've done, this is the whole front end of the detector, well, the input stage anyway. And as you can see, it is one big block of hard stuff. It might even be some sort of plasticized ceramic or something, but you can't get this off, and you can't do anything to it. Look at the connections. How many solder connections are on this thing? You can see them there. But even more interesting on this. Now, like I say, I have pulled these apart before, and it's not really an issue. All you need to get the two boards apart is something like these. Smooth little plier things. And on here, get your fingers in there. Doesn't make much difference which board you want to pull off. I pull this one here off. I squeeze these because there's less components. There's less things to get around. Get your fingers in there and give that a squeeze. Give it a squeeze, and hopefully, I do remember the layout on these boards, so I'm not going to do anything crazy and damage it. By squeezing these in, the board should start wanting to come apart. Okay, it just popped. It went pop about a millimeter. Don't put a lot of pressure on trying to pull it apart. Just move it a little bit. You've got to be very careful with this stuff, that you don't rip things to bits. So on here, give that a squeeze in. And this one here is very tight. There we go, pop. So this is how the poor old technicians, if they repair these, have to do it. There we go, that was easy. Don't put a lot of stress on the board. Move things around, keep it going. Okay. There's a whole heap of surface mounted components there. Don't slip and hit them. Pop. Okay, now there is a connector here at the bottom. We don't want to split the boards more than that angle there, otherwise it'll bend the pins on the connector. Now we're right next to some very, very small surface mount components. You do not want to go whoops and slip and dig the needle nose pliers into those. That would be a disaster. We're nearly apart. Bear with me. And pop. Okay, here we go. As you can see on the board, I'll give you a look-see here. Okay, whoops, that's probably, I probably want to move this back a bit, like so. There you go. You see this connector here? That goes into this receptacle for that for those pins there, the socket. Basically, plug-in socket, but lots of pins here, socket there. That is the two boards. You can have a look under there. It has some, this is the thing that absolutely amazed me. On all the other Minelabs, they grind all the chip numbers off and so forth and cover it up with white paint, as we've seen many times. But these all have the chip numbers on the ICs. No white paint. It probably has a lacquer over it for memory, so it doesn't get water damaged or anything like that if it goes in the drink. I wouldn't do that because it would probably get into the connectors anyway and short them out. But you know, it's fairly chunky sized, decent capacitors here. This will be power rails more than likely. And like I say, it's my opinion. I didn't design it, so it's an opinion. And here, there's a whole lot of tiny components, extremely small, about as big as specks of dust. I don't know if you can see it. I'll try and bring it up to the camera, just where my finger is there. Or maybe over there somewhere. I don't know if you can see that. There's heaps of little components in there. That's why with these boards, you don't want to flex it, like move it that way, bend it or anything like that. That's why I took it off and I just moved it very slightly and let it rest on the pins here and then just pop it apart. Any torsion on the board can basically crack off some of these components, break the solder joints, and it would be a nightmare. You don't want to do that. You want to keep it really nice and clean. But if you have a good look at this detector, it's quite complex on this board here. You know, you could have a look at it and you can go, oh yeah, well there's probably the main guts of it there, the main micro. And I would say by looking at that, that's a FPGA chip. It'll have a huge amount of dot connectors underneath that all the way through, and you don't want to take that off. You can't really probe anything and try and back engineer it. It's a good way of doing a detector, and it'll have the Chinese guessing for years. So I don't think you'll see any knockoffs of this detector. If any do turn up on the market, they won't have this inside it. It'll be something else. I just want to get my eyeglasses, my engineering ones, wherever I put them. They're probably right in front of my face and I can't see them. Let me have a look. I've buried them somewhere. That's the trouble with this room. There's so much stuff in here. Oh, it's over here. There we go. I just want to have a look at some of the small stuff and give a bit of feedback on it. Okay, well that's interesting. The Smart Fusion 2 is the FPGA, a micro semi device, and it has its part numbers on it. So Minelab have done things in a way now that make it very, very difficult to back engineer. Uh, you're not going to get the operational code and functionality out of these things and make another one. It costs a lot of money. They have to do it with scanning electron microscope and multi-layer probing, and I don't think it'd be worth anyone's while. Um, it's actually got good accessible test points all around here. You know, all the test points are labelled. That obviously that would be set up for. They'd make this board, and what they do is they have a test jig. I don't know if they actually do this, but I would. And we have gold fingers sticking up that align with all these test points, and it's an automated test. And you get the board, and you plonk it on there, and it has all the functions tested. It's fed into a computer, and it'll give you a go or no go result on testing the board. It's an automated test. And also with the automated tests that I used to do a few years ago, it would also give you, if there was a problem, it would give you a localized idea of where the problem was. And in some cases, you can make it so smart, it'll tell you what part's wrong, or, at the wrong part's in there, the wrong value, a short circuit, whatever it may be. It'll tell you where to look. So that is very good. And you can always have a look on the boards here that there's, I always look and I have a bit of a look-see all over it. You can see that there's a lot of parts that were going to go on this board here, and they're not there. Not that it's needed for this design to make it work, but obviously they were going to put some other functionality onto this detector. And that's my opinion, not a fact, an opinion. But yeah, looking there, there's some yes, some spots for some ICs and other components that aren't marked as what they are. A couple of diodes. There's a whole interface connector position here, just little holes ready for a connector, and that's no connector, obviously. So, and on the other side of the board, yeah, J201, R215 is not there, R19 is not there. There's a whole heap of stuff that is not populated. Here, D104, not there. There's provision for it because it's in the silk screen. But who knows? What were they going to put in there? Maybe it was a magic discriminator circuit for a PI. I don't know. Only mucking around. So I don't know. U1002 here, it's not populated, but it's funny, the chip's not there, but it looks like all support componentry, such as capacitors and so forth around there are in there. Maybe, I don't know. Let's have a look. What was it? It's got a test point next to it, but I got no idea. And this is a multi-layer board too. I can see that. It has, I'm trying to get an idea. I think this is something like 4 layers. So to try and back engineer a board like this, you really be pushing it uphill big time. This is more like it, the way detectors should be done. And if you have a look here, let's have a look. Yeah, here's your integration stages here. They're 4053s. They're actually labelled 4053, so there's no secrets there. Now, what else we got? Linear Technology 03563, whatever that is. I don't know what that chip is. Yeah, ADS 131E08. Don't know what that is either. There's so many chips in the world, you don't know what they all are. I was having a look at it and get an idea. What's on there? LMH 6612. So all the parts are actually labelled. So it is for if you had a power rail. These things here are for the power rails, right? These probably generate plus and minus 5 volts. You can always tell power rails because they'll usually have larger electrolytic capacitors around them. So that's what that'll be. You know, if anything here, like it's I think it's most of it's just switch mode control chips around there, possibly some series regulators. Like I know you have to go and get all the part numbers and look at it, but you could probably poke if it ever failed, you could probably poke around, work out what was not functioning. You'd probably miss a supply rail, and you could track it back to where it was shorted out or whatever's happened. But you know, it is repairable. It's repairable, much more so than what the other detectors were. Trying to dig for all the paint and all the numbers were rubbed off the chips. But these are quite good. Now back to this side of the board, which I still got connected with this ferrite I see. I'm looking now why it won't come out. It actually has a cable tie around it, around the plastic assembly. So you'd have to snip the cable tie and it'll come out. I didn't remember that, but there's a cable tie sitting here. And I'd say you just cut that and the thing would come out. There's 2 cable ties on it. Yeah. Okay. Yeah, so you can actually get a pair of snippers and it's a cable tie, 2 cable ties. Get in there, snip, snip, don't snip the wires, snip the cable tie. Oh, look at that, the ferrites fall out. Fantastic. Now, now that you can get the ferrites out, only a little hole there. You have to get the rest of this cable tie out, but no big deal. It's easy. Got plenty of cable ties to replace them with. So it's 1 cable tie, 2 cable ties. As you can see, where the wires just go through those ferrite cores, and that's probably, well, not probably, but it is to reduce interference from one section going into the other, or even the pickup wires from the head unit getting back into the control or whatever. But yeah, that's the coil connector ferrite there, and this plastic holder. Last time I did take that out, it just comes out. That's what I'm saying about the cable tie. The cable tie was holding it in. You can see all that white glue, and that was locking it in as well. So into our bucket of parts. Now the bit I am interested in is where your receive signal line comes in, and that's this black wire here. The black wire runs across the top of the board, and where does it go? It goes into the black module. And I say that in a creepy voice because you know, it is an attempt from my point of view, it is an attempt to lock people out doing any modifications on the input stage, and that's where you're going to get a lot of improvements. Now, what I've done in the past, I've done stuff on the input side of the detector. I'll just take these glasses up so I can see what I'm doing. I'll go cross-eyed. And if you try and put in a normal stage as some sort of voltage follower or low noise gain section, the detector won't work. That's what happened last time, and you know, you could run a gain of 2, but it made it noisy. So I'm not doing that again. I've got another idea I'm going to apply, and you know, I think I've a while ago there was a a fellow who actually took an X-ray of this module. I think it's up on Geotech. If you go to geotech1.com and have a look and put in, GPZ-7000, GPZ, it will probably show the X-ray of the module. It has a lot of stuff in here, and I really think that it could even have its own. Well, very very similar to like the dongle in the coil. If you don't have the dongle in the coil with a little I2R data chip in the coil, the detector wants to send a signal to that and wants to get a particular code back. And if it doesn't get the code, it says, well, you're not using the A coil or you're not using the right coil, and I'm not going to turn on. So this is another thing too, what I've done, because you can open up the detector like so. If you actually look in the coil plug on the detector, the chip is inside the coil plug. It's inside molded clear something. I don't know what it is. It's like some sort of rubbery poly something, whatever they used. And what you can do, and I suggest that the average person does not do this because it could end up being a disaster for you, but I have done it on request, is I chop the connector off, right? So I've got the dongle. I work it so I can get the dongle in its plastic encasement out, and very carefully and double checking, I solder that dongle inside the detector on the back of the connector, right? So now it's dongled. No matter what coil you put on it, and it's got to be the right type of coil, like these X coils or whatever they are that come from good old Russia, or any aftermarket coil specifically designed for a GPZ, depending where you're from, of course, that you don't need a dongle. It's already in the detector. So when you turn the detector on, it says, oh yeah, there's a coil connected and it'll work. But I don't suggest the average Joe Blow try and do that. Don't do it. It is critical to do it properly. And then you've got to rewire your coil back onto the plug and put all the wires in the right spot, or else something disastrous will happen. You've got to be careful. But once you do that, you put the dongle there on the inside, you can have your big collection of X coils and make your own coils if you know what you're doing, and do all sorts of things. You don't need to have a dongle per coil. I absolutely I don't like the idea of having chip coils. It's very limiting in any experimentation that you want to do. I would rather have a normal coil setup, but we do live in a capitalist society, don't we? So you have to buy the dongled coil. But that's one way around it. You get around it by doing that. Get a technician competent in working on detectors and solder your dongle on there. Just put it in there. It tucks in here. It's very easy to do for me. It's very easy to do for me. But, it can be done. It's no problem doing that. So that's where I am with this detector. Now I've got to go into all the nitty gritty of doing a whole lot of measurements, testing, and I've got to build up some extra boards, and I'm going to go and see if I can work my magic on this. I have studied this concept huge. I've had third-party consultations with people I know who are extremely good at, on this level, very high level of doing things. So we're going to give it a go and see how we go. The other thing I'll show you too is this module, right? I'm saying that you don't want to try and desolder it and take it out. You'll wreck it, right? And the reason being, if you can see all the pins here. They're from the module soldered through the board. Now, I would say, in my knowledgeable opinion, because I already know, that most of these are earths. They go to the ground plane, the ground plane. I call it ground plane. A lot of people, well, if you're doing circuit board design, it's ground plane. But some people call it a ground plate. Not really a plate, it's just copper on a circuit board. But here, there's a lot of all sorts of different ins and out connections here. So, you know, figuring out what all these are and what they do, it could even have data go into this, and it gets a feedback of data in, data out. And if the module's not there, or it's been destroyed or fiddled with or anything like that, maybe the detector doesn't work. Like I say, it's maybe. But, if I have a look here on the actual connections, notice how I'm holding this board by the outside. I don't put my hand on the inside of it. Because it's all soldered on it, you can't really call it static sensitive as such. Most of these things are bipolar anyway, but let's have a good look. It could have some CMOS in there, but you don't go and rub your hand on the carpet and then go bang on the chip, anything like that. All chips these days, all mod ones, are all protected by input diodes anyway, and usually have ESD ratings at up to a couple of thousand volts. So it's we're not talking the old era of put JFETs in your pocket, wiggle your nylon shirt and blow them up. It's not like that anymore. These things are pretty robust. So just having a look in there, what do we got? Just on this side of it, it goes from pin 1 to pin 43. And that's to do with this module. There's a lot of earths in there, a lot of grounds. I shouldn't say earth, I call it ground. You think I'm talking PowerPoints if I say earth? Same thing, but yeah, there's a lot of control in there as well. So you've got to be careful. I'll tell you one thing though, the transmit stage on this is the transmit stage here that gives you the flipped phase on the transmit coil. So one device does one phase, one does the other, so it just basically flips it like so. Last time I said that, I think Minelab sent me a legal letter or something. So it's my opinion this time. That's what I think it does. I don't know. I'm guessing. But there's a... Yeah, that big square thing, there's an inductor. These are two high current MOSFETs here. Couple of polypropylene type capacitors. They're very high stability, so it could be to do with a timing delay or something. Like I say, I don't know, didn't design it. But you could probably, hook it all up and get it on the oscilloscope and have a look. Obviously, with a power stage, you have a big electrolytic capacitor as a storage reservoir, so you get the current into the coil. So, there's a lot of control chips around there. Very interesting gadget. I remember I did track out the control signal from the dongle on the coil and back into this detector. And I remember it came through here and it went off here somewhere, and it just disappeared over here. And I think it's gone into the multi-layers of board. I can never ever find the other end of it. So, where it's gone, I don't know. It goes in there somewhere, and obviously it turns something on or wants to get the right data. It could even go on to, through a resistor or something out one of these connectors and go and talk directly to the this microprocessor device here, and say, well, if I haven't got that signal, I'm not going to turn on, not going to function. But yeah, I'd say the way this is laid out and everything, I'll give Minelab a good, I give them 10 out of 10. I can't see anything bad about it really. It's quite a good layout. It's if I was designing a something like an RF type radio transceiver or microwave preamplifier or amplifier, I would do it in this format. It's very, very, looks like it's well done. It has internal plane. It probably has a positive and negative internal plane as well. But yeah, I'm probably just as amused as everyone else on these detectors. But even though you can see every component and what it is, I doubt that it's going to get knocked off by anybody. And when I say knocked off, I don't mean stolen. Because in Australia, if you say knocked off, it means stolen. Um, but a knockoff or knocked off in other countries, that means copied. So you basically, I suppose, you do knock it off and then you copy it. So you knock it off and then you make a knockoff. So that's this. Anyway, I'm not going to do a video on all the other stuff I'm going to do. It's going to take me hours and hours and hours doing the tests, and it's where we are at the moment. But yeah, it's a nice little board. I wonder what these cost to buy as replacements. I bet you they cost you a fortune. But yeah, it's very, very nice overall design. I like the way they've done the gold flashing as well on the board. I used to get that done on RF boards. I used to get a gold flash on all the solder, and yeah, it doesn't. Well, on the ones I did, I think it took 5 years for all the lead and nickel to come through the solder and discolor it. So it'll probably, it's got lacquer over it too, so it probably won't oxidize. There is definitely lacquer there. So in most cases, you can touch all this, and you're touching a layer of lacquer. You're not going to blow anything up by static, and not going to do it anyway. It's not the sort of stuff that blows up by touching it. But a lot of the circuitry I used to do in the old days, used to touch it, used to blow up. Um, a lot of CMOS chips just totally unprotected. Used to use ungrounded soldering irons, turn on the circuits and test it. Nothing worked. I did that once at a place. The guy thought he was really smart. He went and pushed the earth connectors into all the soldering irons that all the girls were using, and it actually disconnected the proper ground from the soldering iron. So every time you touched it, it had 24 volts on the tip AC on the tip of the soldering iron, and 24 volts AC through unprotected gates straight into wooden workbenches at the time. So it was conductive as hell, and took all the CMOS chips out. I won't mention the company, but that was a long time ago. You're probably going back around about 1982 or so. Yeah. Anyway, hope you've enjoyed that, because I have, and I'm going to enjoy it a lot more. When I get something up and going, I'll put it on a video and try and point out how I've got around this, well, it's apt, isn't it, really, because it's black and evil. But that's a good little module if you want to do that and stop people fiddling. But I've got a way around that, so I'm going to go and do that. And yeah, anyway, thanks for watching. And guys, if you want to keep up with all this, I've noticed on the YouTube feed type thing that half the viewers who watch this watch them all, but they're not subscribed. So if I put a video up, you're not going to know about it. So do yourself a favor, subscribe to this channel, right? And then when I put up a new video, it'll send you an email and you'll know about it straight away. Because I've got a lot of really good stuff coming up. Not just this. I've got brand new detector designs, different brands you've never heard of. And they're going to probably make everyone's jaws drop. I've said this before, it's getting closer and closer. Don't miss out, because if these things go on the market, I'd hate to go and buy something else and say this thing's twice as good and miss out on it. So yeah, subscribe so you don't miss out on any good information coming up. So I'm going to pepper it with other stuff as well. I'm not just going to stick on this. I've got the 6000 coming, so the 6000 will be having a strip down as well. It's got a module very similar to this, if not the same. And if I can make this do as I suspect I can make it do, well then, guess what? 6000 gets the same treatment. So it could be a really good upgrade for these. And, you know, these are a good detector, but, you know, it, it, it has some issues. Nothing's perfect. They're not made by God, right? They all have issues. So we'll see what we can do, see what we can find, and see what we can clean up. Anyway, that's enough. Catch us later.